So in this lesson, we're going to look at the importance of making accurate measurements. And the learning outcomes, so students should be able to select and use appropriate measuring instruments. So depending on what it is that you want to measure, you need to be able to identify and select appropriate measuring instruments. Okay, so what are some of the quantities then that you will learn how to measure? So there are different skills you need in order to be a good physicist. So measuring is most definitely one of these skills. And some of the quantities you will measure are, so if we talk about length, time, mass, you will measure area, and you'll measure volume as well. Now, we'll go through these briefly in this lesson, but in subsequent lessons we will look at these in more details. And there's also a lot of other properties as well that we will talk about in this lesson and go into them in more detail as we progress through the physics section. So it's very important that your measurements are accurate and that they are given in units that can be understood internationally as well. So each of these quantities here will have a corresponding unit associated with it. So what do we mean by unit? So if we take, for example, the first one, length, so our unit that we would use for that could be centimeters, or it could be, for example, meters, or it could be kilometers, depending on the size, and it could even be millimeters. So when we're talking about units, that's what we mean. Okay, so these quantities. So depending on how big the object is, we would use appropriate units to measure the particular object, whatever it is that we're trying to measure the length of. And similar with the other properties then as well. So why is it important to make accurate measurements? So let's think about a couple of examples of why it's important. So some measurements need to be more accurate than others. So depending on what it is you're measuring and what the purpose of your measurement is, that will determine, for example, how accurate the measurement needs to be. So some measurements have to be perfectly accurate. For example, if you have to replace a broken window pane with a new piece of glass, it has to be the right size. So if it is too small, it will fall out, and if it is too big, it will not fit into the window. To get the right size, you have to make an accurate measurement. So for example, if you have a window pane, something like this, okay, and this window gets broken, you have to be able to accurately measure the dimensions of this window. So for example, if it's too big, so let's say it was, something like this, it's not going to fit in there. Okay, so it's not going to fit. And likewise then as well, if it was like, too small, something like this, it's not going to fit in there either. So your measurements in this case would have to be very accurate in order for the windows to fit in properly. So that's just an example. All sorts of items have to be measured with accuracy. So for example, a DVD has to be the right size to fit into the drive. So again, DVD is circular. It's very important that it's the right size of DVD, otherwise it won't fit into the DVD player. Pieces of Lego have to be manufactured to high degrees of accuracy so that they fit together. And accuracy is extremely important with such things as medicines. So for example, the amount of insulin taken by a person with diabetes may be just right to maintain a correct blood sugar level. So somebody that has diabetes, their body is not producing enough of this substance called insulin. And insulin, basically what it does is it breaks down sugar in blood. So with the insulin not working properly, so imagine you have a blood vessel like this, and you have like normal healthy blood flow. Okay, somebody that is diabetic, what can start to happen is the sugar levels can build up in the blood, and because their insulin doesn't work, what happens is the blood gets very syrupy, and as a result of that, it doesn't flow as easily as it would if the sugar was dissolved in the blood, for example. And then what that can do is that can deprive blood to different parts of the body, and it can have a serious effect on the person. So pharmaceutical companies, they make an injectable product like insulin, and it's very important that that's completely accurate. So if the patient doesn't get enough insulin, for example, if they inject the insulin into their body and there's actually no insulin in the injection, that could be life or death for the individual who is diabetic. So that's why it's very important to have insulin. That's why it's very important for measurements to be accurate. So these are some of the reasons, just some examples, and there's lots of other examples of why it's important to have accurate measurements. So as we mentioned, measurements have units associated with it, depending on the quantity that you're measuring. So why do we need units? It would be unhelpful to ask, for example, to fetch a long piece of wood, nor would it be helpful to ask to fetch a piece of wood of length 3. 3 what? Centimeters, meters. Can you guess how long 3 meters is? So again, that's why it's important, and particularly when you're doing maths and when you're doing measurements, and particularly when you're doing measurements here in science as well, that you state the unit that you're using. Don't just, for example, just write in a number, so 3. Always have the associated units with it. It could be 3 centimeters, it could be 3 amps, it could be 3 volts. Okay, so remember, always include the unit. So the unit of measure. It's really important to include that. Otherwise, the number on its own is meaningless. We use this system of SI units. The name comes from the French system international, the international system of units. By using an international system of units, scientists, engineers, manufacturers, office workers, and other people from various countries can understand each other. So the world more and more is becoming globalized, so it's important that people in different countries can communicate with each other, particularly when it comes to measurements, and we can all understand what everybody else is measuring and the units that they're using. So that's why it's important to know the units and then to use units as well. So the first measurement that we're going to look at is this length. So length is measured in millimeters, centimeters, meters, or kilometers. Now what's really important is that you understand how to move between these different units. So for example, this is a very useful table to learn off and remember. So this indicates, like, let's say, the link between these different units of measure. So 10 millimeters is the same as 1 centimeter. 100 centimeters is the same as 1 meter, and 1000 meters is the same as 1 kilometer. So that's what that word kilo means. Cent means 10, and centimeter, so for example, cent means 100. So centimeter, 100 centimeters is equal to 1 meter. So it's important to know this table and also to be able to comfortably move between these different units. Now, when we're using a ruler, there's a couple of important things to think about. So to measure the length of a copybook, for example, you would use a ruler or a meter stick. The most suitable units would be the centimeter. So if we have a look, so this is like an average ruler, and what we have up here are centimeters here along this line here. Now, when you're using a ruler, it's very important not to make an accurate measurement, and some of the things that can stop you from making an accurate measurement is using the ruler incorrectly. So be careful not to confuse the end of the ruler with the 0 mark. So for example, if we have a look here, we have this end of the ruler, and then you have this 0 mark here that has a line associated with it. Sometimes the 0 mark is exactly at the end of the ruler, so sometimes this is exactly at the end of the ruler, but not always. So make sure that the 0 mark is at one end of the copybook, and then note the position of the ruler corresponding to the other end. This gives the length of the copybook. So for example, you would start your measurement here, and you would line this up with one end of the copybook, and then you would measure depending on how big the copybook is as well. So it's very important that, so if you take out your ruler and have a look, just that you start at the 0 mark. Now sometimes when we need to measure a line, for example, you might get a line that's something like this. So it's not exactly a straight line. So how do you measure? So we start at point A and we're moving to point B. So how how do you measure this length from point A to point B when you have a line that's something like this? So what we can do is we can use one of these guys here, and this is what's known as an oppostometer. So to measure the length of a curve, you would use an oppostometer. So basically what you do is you start with the wheel of the oppostometer at the left side. So you move the wheel, for example, over to the left side. You move the wheel along the curve until you come to the end of the curve. So what happens is you move this guy over here to the left, and then you start at the end of the curve and you wheel it around the curve until you get to the end. And what's going to happen is as this wheel turns, it starts to push over to the right. Okay, so it starts moving over to the right. So you keep pushing this until you get over to the end of the curve, and it'll have moved from left over to right. And then what you do is you place the wheel on the 0 mark of a meter stick, and you roll the wheel along the meter stick until the wheel stops back to the left hand side. So then what you do is you line this up then with one side of a ruler. So for example, if you have your ruler like this, and you have the divisions, and what you do is you take your oppostometer like so, kind of like that, and we look at examples of this in the classroom, and what you do is you wheel it back the way until it goes all the way back over here to the left, and that will tell you then, and then you mark off, for example, like basically where it stopped. Okay, so you'd have something like kind of like this, and what you can do then is you can use this then to measure. This is going to be the length of the curve. But what's really important is that you start at the 0 mark at the end of the ruler. Okay, so the 0 mark, same as when you're measuring length. So that is measuring the length of a curve. So the next one then is one of these guys here, which is called the Trundle Wheel. So again, if we need to measure, imagine if we have, for example, a rugby pitch. Okay, so you have both ends from here to here, and you have to measure from one side to the other. Okay, you want to measure the length of a rugby pitch. So again, you're not going to be able to use like a ruler. It would take you all day. Measuring tape is going to be too short. So what you can do is you can use one of these guys here, which is known as a trundle wheel. And basically it's the same kind of principle as a oppostometer. Every revolution corresponds to a specific amount. And what you do is you'd start on one end and you'd roll it along until you get to the other end. And then just on the trundle wheel, there'll be a reading, and you just measure, you just take the reading from the trundle wheel. And that can be used to measure like big distances. So for example, the length or width of a rugby pitch. So large curve, and you can also use it to measure if, for example, you wanted to, if there was a large curve that's like something like this, maybe it's like a pat, for example, you would use the trundle wheel to get that distance then as well. So large curved lengths are often measured with a trundle wheel, okay, and not just curves, but you can also measure large straight lengths as well. The next kind of instrument then that we can use to measure length is one of these guys, which is called a Vernier Caliper. So to measure the diameter of a coin, you would use a Vernier Caliper. So this can be used to measure like pretty small distances. Okay, so you'd be talking, for example, in the millimeter units of like the millimeter, for example. So really small. And the good thing about it as well is it has these two sides. So this side here would enable you to measure, for example, if you have a coin. So it might be, like a 20-cent coin. And then this other side here, so see the way you have these kind of curves out here. So imagine if you had a piece of pipe. Okay, you can put the two ends, one end in here, one end in here, and you can measure the internal diameter, for example, of a pipe. So that's what these two sides here are for. So if you wanted to measure the outside diameter of the pipe from this side to this side on the outside, you would use this side of the Vernier Caliper. If you wanted to measure the inside diameter of the pipe, you would use this side of the Vernier Caliper. So again, that's measuring length. Now, like what I mentioned earlier, what's really important is in relation to when you're looking at length, you're able to move between the different units. You're able to comfortably convert between the units. So this is an example calculation. So what you're going to ask to do here is convert 8.6 centimeters to millimeters. So what you're doing is you're going from centimeters to millimeters. So we want to convert 8.6. So 8.6 centimeters, 0.6 centimeters equals how many millimeters? Okay, so that's what we're interested in. So what we can do is we can look at this table, for example, and we can see that 1 centimeter is equal to 10 millimeters. So 1 centimeter is equal to 10 millimeters. So if 1 centimeter is 10 millimeters, then 8.6 centimeters is going to be this amount here multiplied by, so it's just going to be this multiplied by that. Okay, so it's going to be, so 8.6 is going to be equal to 10 multiplied by 8.6, and that's going to be equal to 86 millimeters. So what's happening here, you're going from centimeters to millimeters. So you're going from a large unit to a smaller unit. And what you would expect when you're going from a large unit to a smaller, converting from a large unit to a smaller unit, you'd expect the number to be bigger, which in this case it is. So for example, 8.6 centimeters is equivalent to 86 millimeters. So again, this table here is very important when it comes to working out these kind of measurements. So the next example is to convert 67 millimeters to centimeters. So again, we're going from millimeters to centimeters. So what we're doing is we're going from a small unit, millimeters, to a big unit. So you'd expect when you're going from small to big, you'd expect the answer to be smaller, a smaller unit. So what we're being asked to do is, so if we have 67 millimeters, how many centimeters do we have? If we have a look here, we can see that 10 millimeters, so 10, for example, millimeters is equal to 1 centimeter. So what we want to find out is what's 1 millimeter equal to. So in order to change this 10 to a 1, I have to think about what do I have to divide it by. So I have to divide it by 10. And because there's an equal sign here, if I divide this side by 10, I have to divide this side by 10 as well. So that's going to mean, that'll bring it to 1 millimeter is equal to 1/10 of a centimeter. Okay, so 1 millimeter is equal to 1/10 of a centimeter. So now what we want to do is, if we know what 1 millimeter is, we can bring that up to 67. So how do I turn this to 67? I have to multiply both sides by 67. So multiply this by 67 and also multiply this by 67. So therefore, it's going to be 67 millimeters is going to be equal to 1/10 multiplied by 67, which is equal to 6.7 centimeters. So we can see here we've gone from a small unit to a big unit, so we would expect this to be the answer to be a smaller number. Okay, so we've went from 67 millimeters to 6.7 centimeters. So 67 millimeters is equivalent to 6.7 millimeters. So they're just two examples, and we look at other examples in class as well. But these are, you need to be comfortable with moving between these different units, for example, of length. And I've just went through two examples of how to do that. Okay, so the next thing we're going to move on to then is the measurement of mass. So we're measuring mass. So the mass of an object is the amount of matter that's in an object. So mass is measured in grams or kilograms. So if we think about everything in the universe, including ourselves, so it's made up of two things. It is made up of So matter, okay, matter and energy. Okay, and we measure matter we use mass. So matter has two properties. It has mass and it also occupies or has volume. Okay, so they're the two properties of matter. And we measure mass in, for example, grams or kilograms, typically, and we measure volume in mils, and we can also measure it in cubic centimeters as well. So everything in the world, for example, is made up of matter. And what happens then is that matter, it's like an inanimate object, it interacts with energy. So energy, there's all different types and forms of energy, and generally we use the joule. We use a joule to measure energy, okay, and we will look at that in subsequent lessons. But for now, we're going to focus on these guys here, so mass and volume. So we use this to measure matter. So matter is measured in grams or kilograms. Smaller quantities, such as the mass of chemicals that you'll use in the classroom activities, would usually be measured in grams. The kilogram is more suitable for mass if you're measuring the mass of a person or the mass of a large bag of potatoes, for example. So the gram is used for smaller quantities and the kilogram is used for like bigger quantities of mass. And what's important as well is that you know that you can move between grams and kilograms. So 1 kilogram is the same as 1,000 grams. So kilo, this K here stands for kilo, and kilo generally means 1,000. So kilogram means 1,000 grams. So 1 kilogram is the same as 1,000 grams. So that's kind of like where that comes from. And when you see that in front of other objects as well, other units, that means 1,000ths of them. So for example, kilometer. So if you take kilometer, km. So this again it means kilometer is equal. So 1 kilometer is equal to 1,000 meters. Okay, so that's what this kilo. When you see this K in front of a unit, it means 1,000th of those units. So the instrument used to measure the mass of an object is called an electronic balance, and this is like what they typically look like. Most food items that you buy in a supermarket come in packaging with the value of mass written on it. So if you have a look at any of the objects that are bought, any of the shopping, for example, they'll all have the mass of it written on it. For example, a box of cereal, not including packaging, might have a mass of 500 grams. So have a look at that when you're looking at the shopping, for example. Have a look at the mass. It normally indicates the mass on the shopping items, and that allows you to know exactly how much you're getting for the money that you pay. So for example, if you're getting 500 grams of cereal and it costs €3, you are able to make those comparisons as well. So just be more mindful and pay attention to, for example, the units of mass that you will see typically on every household item around in the house, particularly shopping. So when you're measuring mass, so some of the things to take into account when you are measuring mass. So make sure that the surface of the balance is clean. So for example, this surface here, make sure that it's clean before you start to use the balance. If it's not clean, you are going to introduce inaccuracies to your measurement. Make sure that the balance is on a level surface. So again, sometimes if you put it on, some surfaces in the lab might not be that level. So just make sure that it's level. And sometimes some balances, they have like a little spirit level or a bubble here, and there's a circle and then there's a bubble, and you make sure that the bubble is in the center of the circle to make sure that the balance is level. And you have these adjustment wheels at the bottom of the balance to make sure that it's balanced. So again, if it's not balanced, you're introducing inaccuracy into your measurement of mass. The other one is zero the balance. So basically, there's a button that's on the balance and zeros the balance. So it sets the balance at zero. Zero it with a container you plan to use to hold the substance that you want to measure. So typically you don't just weigh things directly onto the, like you don't just spill a powder, for example, directly onto the pan on the balance. What you'll do is you'll use a weighing boat or like a little piece of paper that you'll put on the balance. You will zero the balance and then you will weigh it. If you don't zero the balance, the weight that you get will be inaccurate. It'll include, for example, the container. If you're using like a little weighing boat like this, and then you will put your, for example, whatever it is that you're weighing on the weighing boat, like so. And what you want to do is you want to get the mass of just the object that you're weighing. And you don't want to include this mass here of the container that you're using to measure out or weigh. So what you do is you put this on, you put on the container onto the balance empty, okay, and you zero it. You press the button to zero it and it'll set it off at 0. And then when you start to put in your substances, then you will get a more accurate measurement, so you will have the mass. So you're not going to, if you don't do that, what you're going to get is the mass that you get, the number that you get at the end will include the mass of the container that you use to measure it, and you don't want that. The next unit of measurement that you will use is the measuring time. So time can be measured in many units. So examples are, so you have the second, the minute, the hour, day, week. In science, we use the second, and the symbol for second is this S here. So the instrument we would use to measure time is a stopwatch or an electronic timer, and you would also use a timer on your mobile phone as well. Okay, so these are just some ways that you can measure time, and time is pretty straightforward. Again, what's important as well is that you're able to go between the different units of time. So for example, if you're asked how many seconds are there in a week, so you need to be able to work that out. So there are 7 days in a week, therefore 1 week is equal to 7 days. There are 24 hours in a day, therefore 1 week is equal to 7 multiplied by 24, which is 168 hours. There are 60 minutes in an hour, therefore in 1 week you've 168 multiplied by 60, which is equal to 10,080 minutes in a week. And there are 60 seconds in a minute, therefore in 1 week you've 10,080 multiplied by 60, which is equal to 604,800 seconds. Okay, so that's how many seconds there are in 1 week. So that's a lot of seconds. So again, you need to be comfortable with, similar to with length, you need to be able to move back and forth between the units of time. So the next next thing that we're going to measure is this idea of volume. So volume basically, it has like 3 dimensions. Okay, so you have these 3 dimensions. So volume. So you normally have like length, height, and then you'll have width. So that's volume. Area, then you just have 2 dimensions. So area is just going to be, so for example, length and width. And you will look at these in detail in maths as well. But again, you need to be comfortable, you need to understand when we're talking about volume, what we're talking about. So the volume of an object is the amount of space the object takes up. So typically if you take a cube, for example, something like this, so it's taken up a quantity of space. Okay, so this is volume. So the unit of volume is the centimeter cubed, okay, cm cubed, or the meter cubed. So a centimeter cubed basically would be that each of these sides here are 1 centimeter in length. So it's going to be 1 multiplied by 1 multiplied by 1, which is equal to 1 centimeter cubed. Okay, so this 3 part indicates that it has 3 dimensions. If you take area, for example, if you have 1 centimeter by 1 centimeter, so 1 multiplied by 1, it's going to be 1 centimeter squared. Okay, so notice that you have this 2 here. Why have you 2? Because you're only dealing with 2 dimensions, length and width. Whereas with volume, you're dealing with 3 dimensions. You've length, height, and width. So another important kind of thing to know as well is that 1 centimeter cubed, that's equal to 1 mil. And sometimes you can use what's called a graduated cylinder. And there's other ways you can measure. So you can use this, what's called and we'll look at examples of this later. So you can use like a graduated cylinder, and you can use that to measure the volume of a liquid. You have these other devices called a pipette. So it kind of looks something like this, and we'll show you examples of them. Again, pipettes are used to measure like volume very accurately then as well. So in your maths class, you will learn how to calculate the volume of regular shapes such as rectangular boxes. In science, we also have to be able to calculate the volume of irregular shapes such as small stones, and you'll find on a beach as well. So you need to be able to calculate the volume of regular shapes, but then also the volume of irregular shapes. So as an example here, if we wanted to get the volume of this container here, what we would do is we would just multiply the length by the height by the width. Okay, so you'd multiply the length by the height by the width. So it's just going to be 10 multiplied by 5 multiplied by 8, which is equal to 400 centimeters cubed. And notice you're using this 400 centimeters, the cubed part, to indicate that it's volume. So let's look at some sample calculations. So in this one, calculate the volume of a rectangular box which has a length of 1 meter, a width of 70 centimeters, and a height of 12 centimeters. Now notice with this one here, it has given you different units. So for example, you need to be careful. So with this, it's like kind of like a trick that's in the question. You must change the meters to centimeters. So make sure before you start doing your calculations that all of the units of volume are you're using the same units. So don't multiply meters by centimeters. Convert everything to either centimeters or convert everything to meters. So in this case, what we can say is if we want to get the volume, it's length multiplied by width multiplied by height. So we change everything to centimeters. So for example, 1 meter is equal to 100 centimeters. So we'd multiply 100 multiplied by 70 multiplied by 12, and that's going to be equal to 84,000 centimeters cubed. Okay, so again, it's just important that if you have different units like this, that you convert them all to one unit before you do your calculation. So the other thing that you could be asked to do is you could be asked to get the volume, for example, of an irregular shaped object. Like, for example, if you were to pick up a stone, for example, that's outside, so it's not, there's no like regular shape of, like, for example, the length, and then if you take the width, and then if you take the height, okay, it's very hard to measure that accurately. So what we can do is we can use this method here in order to measure the volume of an irregular shaped object. So how do we go about doing that? So what are some of the things that we need? So for example, we need water. We need what's called a graduated cylinder. Okay, so this here is a graduated cylinder. It's called a graduated cylinder because you have all these graduations here, and typically it'll measure volume in mils. You need one of these guys, which is called an overflow can. So basically an overflow can, you can fill it right up to, there's this nozzle here, so you can fill it right up to this level here. And if you put anything into it, it's going to increase the level of water, and that water will fall down into the graduated cylinder. So we use a graduated cylinder to measure, for example, the volume of a liquid. And you'll need a stone then as well. So how do you do it? So you pour water into the overflow can until some spills out into the graduated cylinder. So you pour it in until some of it spills out, and then you just leave it to make sure it's on a level surface like that. And then you can empty this and get rid of the bit that's spilt out. When the water stops spilling out, you know that the level of the water is exactly at the level of the spout. So this is the spout up here. Carefully read the level of the water in the graduated cylinder and write down the value of the space provided in your student activity book. Okay, so some of the water that's spilled out, just measure that volume that has spilled out. Then what we can do then is we can we can start then to measure the shape of the volume of an irregular shaped object. So you can take your stone, for example, and using a piece of string, you can tie it onto the stone, and then you can start to submerge the stone in the piece of water, in the water. So carefully read the new level of the water in the graduated cylinder and write down the value in your student activity. You can write down in your copy, for example. Subtract the first value from the second value and you'll get the volume. So for example, when you set it up initially, you had an amount of water that's spilt out. So it might have been, let's say, 10 mils. And then when you submerge the stone into the water, it might go up to, in this case, 45 mils. So you just subtract the 10 from the 45, and that gives you the reading of the volume of water that has been displaced by the stone. And the volume of water that the stone displaced is the volume that the stone itself takes up. So another important thing is this. So when water goes into a graduated cylinder like this, it creates this what's known as a meniscus, like a bend in the water. So when you're measuring, you measure from the bottom of the meniscus, not from the top here. If you measure from the top, you will introduce inaccuracy into it. So the top surface of the water in a graduated cylinder is curved a little, and this is called the meniscus. And you'll see that when we're using the graduated cylinders. When reading a graduated cylinder, you must allow the meniscus. Always take the reading corresponding to the bottom of the meniscus to get the correct water level. So you're always reading from the bottom of this meniscus like so. So basically, you will have the water it'll be kind of curved like that, and you don't read from this top part here. You read from this bottom part. So that's where you take your measurement from. Okay, so you line that up with the graduation on the cylinder. So just to introduce you then to some of the other instruments that you will use along our way when we're studying physics, and also when we're doing chemistry as well, just so you're kind of introduced to them and you have an idea of what they are. So it's important that you know what each of these, and you know what they're used to measure. So the first one is a meter stick. So the meter stick is used just to measure length. Okay, so it's generally you measure length you can use a meter stick to measure length. The next one is just a stopwatch. We can use that to measure time. So the units of time would be the second, the minute, or the hour. The next one is the graduated cylinder, which we just briefly talked about there previously. So again, that's used to measure volume. So each graduation on it is normally 1 mil. And just to know as well, 1 mil. So 1 mil is equal to 1 centimeter cubed. Okay, so that's important that you know that. The next one then is one of these guys here, which is a thermometer, and we use that to measure temperature. So the units of temperature are degrees Celsius, the Kelvin, and the degrees Fahrenheit. And we will talk about temperature and go into that in more detail in later lessons. This guy here is what's known as a Newton balance. So a Newton balance is to measure force, and force is measured in newtons, and we'll talk about that in more detail in subsequent lessons. This guy here is an ohm meter, and it's used to measure resistance, and this like horseshoe shaped is what's called the ohm. We use it to measure resistance. So if you take, for example, when we look at electricity, just to introduce it very briefly here. So we remember with the atom, in the atom you have these subatomic particles called electrons. And what happens is, if you take, for example, copper allows electrons to move through it, to flow through it, okay? And electricity is just the flow of these tiny electrons. So some materials will resist the flow of electrons, and they're what are known as insulators. So if you take, for example, if you take a plug, the wire on a plug, the outside of the wire there's normally some kind of plastic covering on it. And the plastic cover resists the movement of the electrons. So therefore the electrons will only move through the copper because copper allows the electrons to move through it, whereas the plastic around the copper wire stops the movement of electrons. So this is what's known as resistance, and this unit or quantity we can measure it using ohms. Okay, so the bigger the amount of ohms, the more the material resists the movement of electrons. So different materials let electrons move through it or resist the movement of electrons to different quantities, and we use the ohm to measure that. The next one is the balance. So again, balance is used to measure mass. We can measure mass in grams or kilograms. This guy here is what's called a burette, and we look at these as well. And again, this is used to measure volume. We can use volume in mils. We talked about the Vernier Caliper. So again, that's used to measure length. An ammeter is used, again, it's relating to the movement of electricity. It measures what's called the amps. And basically what an amp is, it's the amount of electricity that's moving through a piece of wire, for example, or the amount of electrons moving through a particular point in a wire. So that's measured in amps, which is the ampere, and we use this letter A. This is an opasometer. We use it to measure length, the length of a curved surface. We talked about that. We have voltmeter. So this again relates to electricity. It's used to measure the force at which the electrons are moving through the copper wire. So what is it that makes electrons move through a wire? Well, what happens is you have this positive force that comes from the battery, and basically what that does is it pulls the electrons through the copper wire. So the bigger this positive force, the bigger what's known as the voltage. And that's what's known as volts. So you can think about volts as volts is like the force at which the electrons are being moved through the wire. So the bigger the voltage, the more dangerous. So for example, really high voltage is very dangerous. If you touch a high voltage wire that's not properly insulated, the electrons will move through your body and can be very damaging to the internal organs in your body. So we use this thing, what's known as a voltmeter, to measure the voltage. We have this guy here, which is called a pipette, and we look at these in detail as well. So pipettes again are used to measure very accurate amounts of volume. This is a conical flask. Again, it's used to measure volume. This here is what's called a pan balance, and this is used to measure very accurately mass. And this here is what's called a pH meter. And we look at pH in more detail in subsequent lessons. But pH is basically, it goes from 1 to 14. Okay, and then you have 7, which is neutral. So anything that has a pH of 1, for example, or is in, so from, let's say, below 7, moving towards 1. So these are what are called acids. And anything that moves above, that has a bigger pH, these are what are known as bases. And we'll talk about these in more detail in chemistry. But an acid, basically, so if you take in your stomach, for example, you have HCl, hydrochloric acid, and that's used to digest your food. So that is an acid. And if you test the pH of that acid that's in your stomach, it will have a pH below 7. If we take something that's basic, so if you take, for example, the stuff that you use to unclog drains, for example, you will find, so it's normally sodium hydroxide, NaOH. So this is what's called it's a very basic substance. And that's just an example of bases. But we will look at bases in more detail. But what you can do is you can use one of these, what are called a pH meter, and you just stick the probe into the substance that you want to measure the pH, and it'll give you a reading between 1 and 14. And then you can decide then, like, is it an acid or is it a base or is it neutral? So something that has a pH of 7 is neutral, it's not an acid, or it's not necessarily an acid or a base. So if you take, for example, water, H2O, pure water with nothing in it, that would be neutral. So they are other quantities that you measure, and we use a pH meter to measure pH. So that's like making measurements, and then just some of the measuring devices that you will use as a scientist as we work through the science curriculum. So it's just to be aware of those and how to go about using them and how to measure as well. So the last piece then that I just want to talk about in this section, so ethics in measurements. So this is very, very important. So when you buy petrol, so for example, when your parents buy petrol or diesel, or when you buy petrol or diesel, when you get your license, you're able to drive, the amount you pay depends on the volume of fuel you put into the tank. So if the pump is faulty, the amount you pay is not the amount that you put in the car. So for example, if there was no ethics and people that own petrol pumps were unethical, what they could do is they could, for example, so it might say that you've got 2 litres of petrol or diesel, but that measurement might be inaccurate. So it might actually only be giving you 1 litre. But nonetheless, you have paid for 2 litres. So this would be like unethical. So if this was happening, so what happens is there's checks that are done randomly on petrol meters to make sure that this doesn't happen. So again, the same thing can happen if you, for example, if you're measuring mass and you don't record it properly, or if you are measuring volume and you don't record it properly, or any measurement, if you don't record it properly, you're going to be introducing inaccuracies into your experiment or into your measurements. And if you do that, it's unethical. So basically, or even if, let's say, you don't even do the measurement, you just make up a measurement. So things like that can happen in science, and they lead to major problems, because what happens is you can't trust the information that you get, and as a result of that, you are introducing inaccuracies into your measurements, and it's unethical. So it is. So that's the last kind of piece. So that is, let's just go back here. So just to go back to review the learning outcomes, so students should be able to select and use appropriate measurement instruments. So depending on what it is that you have to measure, you have an idea now of, let's say, the types of instruments that you can use to measure the different quantities that you want to measure. Okay, so thank you for listening.